Oh gosh, that's loud. Okay, so let's see if that works. Hey guys, on the group chat, does it work? Give me a quick thumbs up on the group chat if you can do that. Oh, cool, I can do a pop-out chat. Ha! Okay, how are we doing? So there is a live chat going on and I think that should work. Yep, that works. Hey, cool. We are in business. So, what else do I need to do? How many people are actually there? Now I have to wait a few more minutes. So I can see actually the live chat from YouTube. Ah, good, Asma here, great. We've got people coming in, excellent. So that's working nicely. So if you've got any questions or any problems, please post them on the YouTube chat then, or on the group chat. I can see both at the moment, so that should be okay. And hey, how cool is that? I'm sitting in my warm office and don't have to worry about anything. Ha! Technology, it makes it possible. And I hope the quality is reasonable as well. Okay. So let's give it another minute or so and then let's go through that. So here is the question. And we've got a typical buffer question. And I'm not saying that it will come up in the test, but it might. So it might be you. Okay, so welcome to this live stream, sort of ad hoc, to see whether we can do that and if people have problems. So here's the question. pK of a weak acid is 7.16. pH of the corresponding buffer is 7.27 and the total capacity of the buffer is 431 millimolar. using an acid with a molecular mass of 154.37 gram per mole and a base with a molecular mass of 169.57 grams per mole, you are required to prepare 182 milliliter of this buffer. How much of the acid and the base do you have to weigh in? So the first step, really the first step, is where you have to ask, do we need more acid or base? So we know that the pKa is 7.16 and the pH is 7.27. So we know that the pH is actually larger than the pKa. And if that is the case, we know that we need more base than acid. And if you write that down already at that point, then you can't really go wrong, because that can be used to check later your results. So, okay, now how much more base do we actually need? Well, we can use our Henderson-Hasselbalch equation. So pH equals pKa. And we can either write it as minus acid over base or plus base over acid. It does not matter at all because both is the same. I write it in this case plus the logarithm to the base of 10 of concentration of the base over the concentration of the acid. And now I just need to rearrange this equation. So I have log base over acid equals, we bring this pKa to the other side. So we have pH minus pKa equals 7.27 minus 7.16, and if my maths is correct, then we have 0.11 as the difference. Am I correct? Thumbs up? Good. Are you still here? Okay, I assume somebody is here. Okay, so what we then just simply do is we take both sides to the power of 10 to get rid of the log, and we get the ratio of base over acid equals 10 to the power of 0.11. And if we put that into a calculator, we would get base over acid 1.29. So we know that we have, so we can say we have base equals 1.29 times the acid concentration. Let's put the brackets around that as well. So we have that, and we also know that the base concentration plus the acid concentration, if we put them together, then we get the capacity of the buffer, which is 433.1 millimolar. So 433 millimole per liter. So what we have got now is just simply, we have two equations, and we just simply put this, instead of base, we can write 1.29 times acid, so we have 1.2 times the acid concentration plus the acid concentration equals 431 millimolar. Or I can factor out the acid. I've got acid times 1.29 plus 1 equals 431 millimolar. And if I want to get the acid, I just simply divide. So my acid concentration is 431 millimolar divided by, well, 1.29 plus 1, that gives us 2.29. And if I put that in my calculator, I get roughly 188.2 millimolar. So that is my acid concentration. Okay, that makes sense? Are you happy with that? Good. Emily says thumbs up, so it makes sense. Great. And now we just do the base concentration. So for the base concentration, we just simply say this is our 431 millimolar minus the acid concentration, minus 188.2 millimolar. And can we do that in the head? Probably not. So that gives us 242.8 millimolar. So that is our base concentration. And now here comes the reality check. Here's the nice thing, because we said earlier we need more base than acid. So more base than acid, that is what we said. And lo and behold, we see we calculate more base than our acid. So we know that we are on the right track. So that's sort of our reality check. So what are we going to do with these things? Well, basically, it boils now down to a different problem. It boils down to make up milliliter 182 milliliter of let's go for the base first, of 242.8 millimolar solution. And the molecular weight for the base was 169.57. Molecular mass is 169.57 gram per mole. So that is now our task. Are you still happy with that? Does that make sense? Asma says yes. Good. Great feedback. Very, very useful. Okay, so how can we do that? There are loads and loads of different ways how you can address this question. Whichever way suits you, it doesn't make any difference to me. As I said, I like the dimensional analysis, where I don't really have to learn any equations, where I'm just simply guided by my units. So I am asking, how much of the base do I need to weigh in? And weight is usually measured in grams, so I write down my grams. Here are my grams. Do I have anything with grams on it? Yes, I've got this bit here where I have grams, so I just simply write 169.57 gram per mole. And I see I've got my grams already in the right position. So all I need to do is get rid of this mole. Do I have mole anywhere? Yes, I've got my moles. They are hidden in this one here. Oops, I just didn't mean to delete that. 242.8 millimolar that was. I just wanted to highlight that. That's better. So, and I can write this as times 242.8. Now, careful with the milli. That is times 10 to the minus 3. And the molar stands for mole per liter. Now, I can really cancel out the mole. And all I need to do is try to get rid of the liters. Do I have liters anywhere? Yeah, that's what I've got here. So I multiply that by 182 times, and the milli is 10 to the minus 3 liters. Now what have we got left? We can cancel out the liters. And all we have left is really the grams here, and that is exactly what we want to have. So all we need to do is we have to put that into a calculator, and I leave you to do that, so to get some practice. I give you a minute or so and just simply try to do it and see what you get. Post it roughly how much base do we need if you do this calculation. So base, what do you get? Get your calculator out. Asma says 7.5 grams. Are you happy with that? Does anyone get anything else? Jayla, 7.5. 7.5. Don't forget the units, okay? 7.5. Is it bananas? Please, in the exam, put down the units. So that is 7.5 gram. And I fully, yes, thank you. Yep. So I fully agree. I get 7.5 grams as well. Now, if some people give me 7.483876578 grams, yeah, whatsoever. I mean, you have done significant figures. I will not mark you down if you give me far too many significant numbers, but it's just simply not good practice. So just revisit what you have done for significant numbers. So that was our base. That was the amount of base that we need to use. Now let's go to the acid. And here again, the problem is make up 182 milliliter of 188.2 millimolar solution, and the molecular mass for the acid, let me just quickly check, that was 154.37. 154.37 gram per mole. Now I do basically exactly the same thing, just slightly different numbers. So I do my grams, that is what I'm looking for. I have my grams in here. So I have 154.37 gram per mole times, now the grams is in the right place, I just need to get rid of the mole. Do I have mole anywhere? Yep, it's in here in this 188.2 millimolar, so that's 188.2 times 10 to the minus 3, that's the milli mole per liter. And Joe says it's 5.29 grams. Let's see if he's right. So I cancel out the mole. All I need to do is now get rid of the liter, and I had this with 182 times 10 to the minus 3 liter. Now I can cancel out the liters, and if I hack that into my calculator, I get the amount of acid equals 5.29 or 5.3 grams. And Joe and Asma are right. So this is actually how you do your calculations for a buffer. So you see, I have done it quite slowly now. How long did it take us? It took us 17 minutes. So really not terrible. Would potentially lend itself for a test, but you know, we shall see if something like that comes up tomorrow. Are you happy with that? Very happy. People say yes. Thank you. Brilliant. So now you know how to do it, and actually, please don't stress about the test tomorrow. So what's coming up? Well, I am going to read my emails now. And for you, Joe, I think you probably have an enjoyable afternoon. And as I said, it's not worth stressing. It is a gentle test which allows you to shine and show me what you have done. Okay, so mic drop. Thank you very much for watching, and see you around. Take care. Bye-bye.